Welcome back to Pre-Algebra with Miss Betsy. Today we are going to be talking about how you calculate simple interest. This is the last section in the chapter where we've been talking about use of percentages in word problems, and we've reviewed how to indicate a percentage as a decimal number, as a fraction, and simply using the percent symbol. And we're beginning to understand how important percentage is in real life word problems. Because a lot of times people will say, well, what in the world do I need algebra for? What do I need pre-algebra for? So there are lots of real life application with percentage, and one more of those that we're working on today is simple interest. Before we get started though, I've got a lame joke for you. I have my best friend always says, would you hurry up and grow that money tree so that I can get the money that I'm looking for? So where can anyone always find the money that they want? In the dictionary, of course. You can always find money right there in the dictionary. Section 10.7 in my text, which is Bob Jones University Press. It's published by them, first edition of Pre-Algebra for Christian Schools, and I'm on page 334 in section 10.7, simple interest. And you see here that I have lost my green marker. Well, you don't see that, but I'm telling you I lost my green marker. So I'll use this orange marker. Already written out simple interest, and there's a formula that you use to calculate simple interest, and it's I is equal to PRT. And the I simply represents simple interest. There are two different types of interest in the financial world. You can have simple interest and you can have compound interest. Without getting into any level of technical differentiation here, simple interest, you earn the least amount of money or you pay the least amount of money. Say that you have $1,000 that you've invested, you get simple interest, and at the end of 10 years you've been very fortunate and your money has doubled to $2,000, but you haven't changed anything around, you're still getting simple interest. You're only earning interest on the initial $1,000 that you paid. Compound interest is where you earn interest on your interest. But anyway, what we're going to be calculating is just simply what they call simple interest. And simple interest is the product of principal times rate times time. And what all principal is, this is the amount of money that you borrow, amount of money that's borrowed, lent, or invested. And that's always a particular amount. We typically talk about it in dollars, not dollars and cents, but it's the total amount that you borrow. Interest is what they would call, and defined to be, simply rate of interest. And this is always going to be a percent. And when a lot of these books were published, the older ones, they would talk about 8% interest or 10% interest or 7% interest. If you look around the world today now, we're not getting interest rates anywhere near that high, but rate of interest is always a percent, and this can be the amount of money that you borrowed, that you've lent, or that you've invested. Invested is another way for saying that you've saved that money, you've set it aside, maybe just in a savings account, or you've invested it where you've said to someone else, okay, I'm going to give you this money for you to use to create something of value. Finally, the T represents the amount of time, or how long that money is actually being used. And the units of the time are going to be important. It might be a rate of interest per month, a rate of interest that is annual, which would be per year. So interest is principal times rate times time. And it's a very simple, very straightforward calculation. This is like so much of what we've been doing lately. The problems are not difficult. You simply have to have an understanding of the definitions. So let's go ahead and look at this first example in Chapter 10, Section 7. This says, Aaron borrowed $465 for 1 year to buy an 18-speed touring bicycle. The rate of interest is 15% per year. How much interest will Aaron pay? What's the total amount of money that Aaron will repay? Okay, well, let's update this problem, and maybe he's going to, of course, now I can't call the name of a good road bike, but what you might be doing now is you might be spending $465 for a 30-speed road bike that you got on sale for a killer sale. You're getting a used road bike for $465, and you're going to borrow that money from the company. You're going to say, okay, I'll use a credit card or I'll open an account, and I could go on for a whole video about why I don't think that's a good idea. But I won't. But this problem, he's borrowing $465 for a year to buy a bicycle. 15% per year. How much interest is he going to pay? And what's the total amount of money that Aaron's going to pay for this bicycle? So what's our formula for interest? We're going to assume that when we are doing interest problems in Algebra 1, and then again in pre-algebra and in Algebra 1, that we're talking about simple interest. So we look at this problem and we see two questions. We want to know how much interest, how much is the interest, and how much is the payback. Aaron didn't have the $465 to buy his bicycle, so he's borrowing money. So first we're going to figure out the cost of his borrowing, and that's the interest. How much money is he borrowing? Our book tells us that he's borrowing $465. What is the rate? The rate is the interest, and it's a percentage, and you're going to express that as a decimal. So you have to know that 15% expressed as a decimal is 0.15. And then how long is he going to borrow it? The time, he's going to borrow it for 1 year, and the rate of interest set was 15% per year. So your units have to be the same. If the interest is per year, the time is per year. Okay? What is his interest going to be? Going to do this multiplication. You may go ahead and use your calculators. 465 times 0.15 times 1, and the amount of interest is $69.75. $69.75. That's the first part of our problem. Now our problem asks us, what's the amount of interest that over the course of a year Aaron has to pay for the privilege of buying his bicycle right now instead of saving up the money for it? Well, it costs him $69.75, so that's the cost of borrowing the money. Now my little shameless plug here for not borrowing the money. So you wait until you can pay cash for that bicycle, and you've actually saved $70. Whether you choose to give that $70 to somebody else, to use it to support a missionary, to use it to buy your helmet and your camelback for your bicycle instead of having to go ahead and buy something else. If you choose to use it to go out to eat with a friend and go to Six Flags, when you are borrowing money, there's an expense involved in that. Okay, now the second part of the question was, what is the total amount of money that Aaron will repay, the amount of money that he'll pay back? And back to this whole idea of interest. We get sucked into the idea of borrowing money by saying, oh, well, it's only so much per month, because Aaron would have paid a certain amount per month to the bike company or whatever, and they think, oh, it's no big deal. And it isn't in our minds until you realize that, oh, hey, man, it cost me $70 more for the bike. So there's a whole lot to be said for setting aside money and saving it. So the payback, How are we going to find the amount of money that Aaron pays back? Well, that's very simple. If we're going to find the total amount of payback, or the total amount paid, and you guys know what this is going to be. The total amount is going to be the principal plus the interest. So how much is he going to pay for this $465 bike? I'm just going to call this the total amount is the principal of $465 plus the interest of $69.75 gives us the total amount that he pays. I'm going to cheat here, $534.75. This is the total cost of the bike. Now you see here that there's nothing difficult about the actual math that we're completing here, or just multiplying numbers together. What you have to know is the formula for finding interest. You have to know that rate is used as a percentage, and you have to know that the time that the money is invested and the time associated with the interest rate has to be the same. And then you have to know that the total amount that it's going to cost you for whatever it is that you're buying is not just the interest. That's how much it costs you to borrow the money. The total cost of the item that you're buying is what it costs to borrow the money, the interest, plus the initial cost of your purchase. Okay, so let's go ahead and look at another problem here. In this one, we're going to just leave this formula up here for interest. We're going to see that the problem tells us on page 335, find the interest and the total amount owed on $1,500 borrowed at 1.5% per month for 9 months. So let's go ahead and write out to the side here the pieces of information that we have. Well, we're going to borrow. The amount we borrow is going to be the principal, isn't it? It's $1,500. What else do we have? We're going to borrow it at 1.5%. Whoops, not 1%. 1.5% per month. So what is this in our formula? This is our rate. The rate that we have is the 1.5% a month. And how long are we going to borrow it? Our problem tells us that we're going to borrow it for 9 months. And what are our questions? What do we want to find? We want to find out what's the interest, and what is the total cost. See how they phrase it. Find the interest and the total amount owed. Total amount owed is what does it cost you to borrow $1,500. You're only going to borrow it for 9 months, and the rate of interest that you're going to pay, of simple interest that you're going to pay, is 1.5% per month. What's your kicker here? First off, make sure that the time is the same with the rate and with the time. We're talking about months, so we can multiply everything directly. So interest is going to be the principal of $1,500 times the rate. What is our rate? It's 1.5% per month. How do you indicate 1.5%? Well, it's 1.5%, isn't it? But our rate has to be given to us in decimal. So do not make the mistake of saying that that's 0.15. That is not 0.15. 1.5% is 0.015. 1% is 1/100th. 0.5% is your 5 carries over into the thousandths place. So 1.5% indicated as a decimal is 0.015 per month. And what is our time? Our time is 9 months. The units would cancel out. The months divide by months to be equal to 1 year, but that's really something that's ahead of where you are right now. So what you need, all you need to worry about is making sure that the units, that the rate, percentage rate is expressed in the same time period as a time. Month, month, year, year, day, day. And as long as they're the same, you directly plug the values into this very simple formula. Interest is equal to principal times rate times time. Use your calculator. Make sure that you have an understanding of what is going to be a reasonable amount. And I'm going to go ahead and use my little cheat sheet here. And that answer is going to be $202.50. This is the interest. Now, if we're borrowing $1,500 for 9 months at this interest rate, this is how much extra it costs us. But let's say that we're the bank and we are lending you the money. Or let's say I'm the bank, you know, I'm not borrowing it from somebody, I'm charging somebody else interest. That's how much money I make. Okay? That's how much money I as the bank make. The interest here is $202.50, and the total amount that we're paying for the privilege of borrowing $1,500 is the principal plus the interest, which is $202.50. So our total amount is $1,702.50. You see that these are just very simply plug in the number. Make sure that if you're doing these calculations by hand, that you locate your decimal point correctly. If you're doing these calculations by hand using a calculator, make sure that you're paying attention and that you can realize that if all of a sudden, you know, you punch something into your calculator wrong, you didn't know that you did it, but all of a sudden your interest paid ends up being $2,025, be aware of what you're doing. Your interest is not going to be bigger than the principal that you borrowed with the types of problems that we're working on. So make sure that you are paying attention to the reasonableness of your answer. Okay? Now I've said twice, and I've made a little bit more of a big deal about it this time, that the units on the rate and the units of the time that you invest the money or that you borrow the money or that you loan the money, that time, the units have to be the same. So let's go ahead and do a problem now where the units are different. And this is going to be example 2 on page 335. And we'll go ahead and read this problem. This problem says, consider the following example. Find the interest charged, $3,000 at 8% per year for 15 months. Okay? What's our problem? Our problem here, $3,000 at 8% per year, and sometimes they'll use a very fancy looking Latin word, per annum, per year, 8% per year for 15 months. Okay, so we have our problem is given to us. We have our principal, it's $3,000. We have our rate, it's a percentage per time period, which is year. And we have the time that we are going to borrow the money, but it's months. You see what we have here? We have two different units. We have year and we have months. And what you have to have the same here is the rate must be the same units as the interest. Because you're not going to be manipulating your interest rate, changing that from 8% per year to 8% per month, because that's not necessarily the way that it is. A lot of the time with simple interest, matter of fact, I think all the time, but I'm not certain, if you have annual interest, that may be paid one time. That would be you have your interest there, and you don't earn any interest until you've had that money in there for a year. It's not that you can break it up into, annual interest is the same as breaking like a third of a percent per month, which is not correct. 0.5%, I don't know what I'm coming up with out of the top of my head, but you're not going to mess with the units on the percentage. So you're going to have to convert months into years. And this time, we're wanting everything here at this point to be using decimals. So let's think about what we have. How many months are there in a year? Well, there are 12 months in a year. So if you actually have 15 months, you're going to divide that by the number of months in a year to give you how many years you are borrowing that money. That will actually reduce to 5/4, which is 1 1/4 years. So, this right here, if you have something expressed in months, something else expressed in years, you have to make sure that those units are the same. Then we simply plug this in. Principal is 3,000. Interest is 8%. And how do you write 8% as a decimal? 0.08. 15 months expressed as a decimal is 1.25. Go ahead and do all of your multiplication on this, and you end up with the amount of interest charged is $300. And that's the end of your problem. Why is this the end of your problem? Why didn't we come up with the total amount? Where the total amount was the principal plus the interest, which would be 3,000 plus the interest, which would be 3,300. Yeah, that would be true, but our problem didn't ask us for this. All they wanted to know is what's the interest if I borrow that money for a year and a quarter, for 15 months. So read your problems carefully. There's nothing to be psyched out about on these at all. These are real straightforward. Just be careful with converting percentage to decimal form, and be careful when you have to go from months to years. Okay? I'll see you next time.